Hello everyone, welcome to the video. And in today's video, we are going to talk about NumPy. What NumPy is, why is it used, and then we'll be creating a mini project in NumPy, that is a complete sales analysis project, in which we'll be manipulating the data or making changes to that data or doing calculations and other things on the data using NumPy modules and functions. So as we know that NumPy is a Python library that helps us to do data manipulations in a much faster way than what we can do using Python list or Python any other data type for that matter. So in this video, we will be seeing what NumPy is, why is it used, and then in the mini project, instead of hard coding the data, what we'll do is that the user will enter the data at runtime. So this will make the project more interactive, as well as it's a great way to practice Python and also do data manipulations and calculations in real time to understand the modules of NumPy in a much better way. Okay. So if you're finding our videos useful, don't forget to like, share and subscribe to the channel to get more such videos. And now let's start the video to understand about NumPy. Okay. So what is NumPy? So NumPy, which is short for numerical Python. This is a short form. The full form is numerical Python, and NumPy is an open source library or an open source Python library to work with arrays, to work mathematical operations and handle large data sets in a much efficient way. So this is a core library of Python. So if you're wishing to transition to a data science field, then Python is the core library in the data science stack that is used in everything from AI to finance and to any other thing. So NumPy is short for numerical Python. This is our core library of Python, which helps us to work with arrays, to do mathematical operations, to handle large data sets in much efficient way. So this handles large data sets much faster than normal Python. The operations are very fast. It is the foundation of many other libraries such as Pandas, SciPy, Scikit-Learn, TensorFlow, PyTorch, which is used in AI and in other places. It allows easy mathematical operations, statistics and linear algebra, which are core in data science. So someone in the data science field, they must be using mathematical operations, statistics and linear algebra to do their everyday tasks. So NumPy makes those process or those tasks easier by the modules, by the functions it has. So without NumPy, data science in Python would be very slow. So this is a core library that helps us to handle large data sets, foundation for other libraries, and helps us to do easy mathematical operations, statistics and linear algebra, which are core in data science. So for someone in the data science area, NumPy is a must for them to understand. Okay, so this was NumPy. But if you have a question that okay, why should I use NumPy? If I have a Python list, why not go ahead with that? This will also do the same thing as what NumPy will do. So let's just see an example. Why not just use Python list? So let's say that you want to add 10 to every number to a list. So let's say we have a list here, which is, so let's say we have a list here. The variable is data and the data is handling 1, 2, 3, 4, 5. This is the data that the data is handling. This is the variable name and this is the data that is handling 1, 2, 3, 4, 5, right? So I want to add 10 to every number to a list. So in one, 10 should be added, in 2, 10 should be added, 3, 4, 5. The result should be 11, 12, 13, 14 and 15 to add 10 to each number, right? So what's the next step? In the result, this is a variable here. So this is running a loop for x in data. So x is the variable that it's taking, and in the data, for x in data, add x plus 10. So this will take this data, add 10 to it and then move ahead. Then this will take this data, x, add 10 to it and then till it reaches 5, it will add 10 and then the result will be printed, which is 11, 12, 13, 14, 15. Alright. So this is the result that we are printing. So why not use Python list? Well, we'll see that in the next slide, which is if we are using NumPy. So if the same scenario, that is we want to add 10 to every number in a list. So we had used this before. Now if I wish to do the same operations using NumPy, so first we'll have to import NumPy as NP. NP is a short form so that we don't have to write NumPy everywhere. So this is the library of Python. So we have to import this as NP, and then this is the variable name data, the same that we had in list, and np.array. So since as we know that NumPy helps us to work with arrays, then this what will do that this will take this as an array. 1, 2, 3, 4, 5. This also takes that as an array. So, but here we have to specify that we are using an array. So, np.array, and we have taken the same values. Now, simply data plus 10. We do not have to run a for loop. We do not have to take every value there and add plus 10, plus 10, plus 10, and then end may print the result. Here, the variable is taken and 10 is added to that directly and giving us the same answer. So this was faster than the previous list, because there we were running a loop, then we were adding all the data to each and every value by incrementing them from 1 to 2, then 3, 4, and then 5, and then in the end the data is being printed, the result is being printed. But here in NumPy, the variable name is taken and 10 is added to it. No loops are used, and no increment or decrement are being used here. Okay, so the answer is the same here. So this is called vectorization, that is applying operations on the whole array at once. In list we cannot do that, we cannot apply the whole operations on a single array, we have to like iterate that. But here in NumPy, using the NumPy array functionality, we can apply operations on the whole array at once. Just add 10 to the array, and that 10 will be added to each and every value of the array. Okay, so this is the difference between NumPy and list, that this is much faster and this is more easier to understand, more easier to remember, and takes lesser time and lesser resources or the memory. Okay, moving ahead. So if you are using NumPy, then you must understand, or you must know what ND array is. So what is ND array? ND array is short for n dimensional array. N dimensional array, right? So ND array short form is n dimensional array, and this is like a Python list, but it supports multi-dimensional data. It helps in efficient storage and fast mathematical operations, which is kind of a backbone of NumPy. So an n-dimensional array is a Python list, more like a Python list, but it supports multi-dimensional data, efficient storage, and faster mathematical operations, making it the backbone of NumPy. So we can think of it as a table of numbers, all of the same data type, like the table is of the same data type. If it's of int, then the same table, then all the numbers are integer. If it's float, all the numbers are float. So this is, think of it as a table of numbers in which all the numbers are there of the same data type, stored in the memory efficiently. So if we take as one dimensional array, then this is the data type, and the array is 1, 2, 3, 4. This is one dimensional, this is just taking one dimension. It's two dimensional array, which is, these are like rows and columns. We can also call them as a matrix, and using ND array we can do various functionalities on it, that we can print the dimensions, how many dimensions has, the shape, the type, the data type, etc. And this will give us the value. Like if I want to get the dimensions of this array, then just have to print arr2 dot ndim, n dimension, any ndim, arr2 dot ndim, cannot write properly, this is dot arr2 dot ndim, and this will give us the dimension of this 2D array. Okay, which is the dimensions are 2. It will give me the shape, this will print the data type that it has, this is an integer value, this will print the integer value, right? And the same for 3D array, where it can print the width, the height, and the channels. This is the larger arrays compared to the 2D arrays, and used in images with width, height, and channels. So why should we understand ND array? Is that this is, first, it is a core of NumPy. Second, if you are using machine learning, or if you want to transition to data science or to AI, then it's essential to understand ND array, because this replaces Python loops with fast computations. That is, it uses it stores data in contiguous blocks of memory. Whatever data is stored here, it's stored in contiguous blocks of memory, and helping ND array to handle billions of data points in seconds. Plus, it's easy to integrate with other libraries such as Pandas, TensorFlow, and others. So this makes the operations of NumPy, that is, makes the operations of data and other things in a much faster way as compared to other Python data types. So there are some key points that we need to understand to work with ND array. That is, it can have any number of dimensions. It can have 1D, it can have 2D, it can have 3D, 3 dimensions. For images or for deep learning data, if you are using deep learning, then you'll be using 3D array there. Second, it should be homogeneous. That is, it should have data of the same data type. That is, if they are all integers, then they should be all integers. If they are float, then it should be all float. So this makes the ND array, or this makes the computation faster and more memory efficient than regular Python list that we use. Third, we can do mathematical operations on the entire array as once, as we have seen in the previous slide that NumPy helps us to add the numbers on the complete array without using any loop. So this ND array also allows us to do mathematical operations on the entire array without using loops. So this operation is called as vectorization. Performing operations on that directly is called vectorization, and this is the biggest advantage of using NumPy arrays, that we can do vectorization of data using the whole arrays at once. Plus it's memory efficient, it doesn't take much memory, and it can be used everywhere in data science, in machine learning, in image processing, in scientific computing, and it's often the building blocks for complex structures that uses NumPy, or that uses libraries such as Pandas, TensorFlow and Scikit-Learn. Okay. So if you want to understand more about NumPy, or if you wish to transition to data science or to AI, then understanding ND array as a part of NumPy is very essential. Okay. So why NumPy is important in data science? So as we know that NumPy is a Python library that is primarily used in data science, and it's the core, or is the backbone of data science. So why is it important in data science? First, it's fast and memory efficient. It can handle millions of rows and use them efficiently without taking much memory. Then it's the foundation for Pandas, which is used for real data sets. Is the foundation for Pandas, which is an open source Python library as well, much like NumPy, used for data manipulation and analysis. So it's built on top of NumPy. So if you are not understanding NumPy, then understanding Pandas will be difficult. So this is built on top of NumPy and works with structured data, that is on tables, on Excel sheets, on spreadsheets in a much faster way, right? This is the core for ML and AI, machine learning and artificial intelligence. Every library uses NumPy internally, as this is the core library for data science or for machine learning or artificial intelligence. Plus it's easy, it helps us to do the math, the stats, the matrix operations and sampling in an easier way. That is, we do not have to do everything manually, or do not have to do much calculations and other things. NumPy libraries and NumPy modules makes the calculations or the operations easy. Okay. So the final thoughts here are that NumPy is the heart of the data science in Python. It provides us ND array, which helps us is in multi-dimensional arrays, 1D array, 2D array, 3D array, providing various operations on that. Then it helps us to do the bar statistics, linear algebra, random sampling super fast using the NumPy modules and the NumPy functionality. And this is essential if you wish to understand other libraries of Python such as Pandas, Scikit-Learn, TensorFlow and PyTorch, and transition to data science or to the AI. Okay. So NumPy is the heart of data science in Python. So now that we have covered the basics of NumPy, that what NumPy is, so now let's transition directly to creating the project in NumPy to understand how NumPy works. And we will be not hard code the data, but we'll be entering the data at runtime. That is, the user will enter what data he wants at runtime, and then the NumPy modules and then the NumPy functions will work on that data, and we'll see what are the results as compared to other Python data type that we have. Okay, so now let's go ahead with the, so now let's switch to the project and create that. So now let's start with the project, and before that there are some prerequisites. It's that we have to install NumPy onto our system. So if there is no NumPy onto your system, then the program will throw error that the module is not found. So we have to first install, and then only after that we can create the program and get our appropriate results. Okay. So for that, first of all, let's create a directory first. In that directory, we will create a virtual environment, and then in that virtual environment, we will be installing NumPy. And after that, the NumPy is installed, then we'll create the NumPy file and start with the program. Okay. So first create a directory. I'll make the directory name as NumPy tutorial. Okay, and navigate to that directory. Okay, so you can see there is nothing in there. So in this directory, what we'll do is that first we'll create a virtual environment. Okay, command to create a virtual environment is Python 3. So in my machine Python 3 works. If in your machine Python works, go ahead with Python and the virtual environment and the name. So I'll take the name as venv only and press enter. The virtual environment is created, but we have to first activate it now. So to activate, we'll go source, the name of the virtual environment, /bin/activate. Okay, and this has been activated. Okay, so you can check here by this command, and here you can see the venv is there. This has been created and this is activated. Now here in this place, we'll install NumPy. So the command is pip install NumPy and press enter. So NumPy is being installed here. So NumPy is not now installed. So now let's go and create the program, and I'll be using Visual Studio Code here to create a NumPy program here. So now we'll create a file here and I'll name it as num.py. Okay, so do not name it NumPy, because if you name it NumPy then it will confuse your application name and the module name. So even if NumPy is installed onto the system, this will throw error because it will think that you are calling the program that you have created with the name of NumPy. So do not name it NumPy and name it num.py. And here let's write the program. So the first line is import NumPy as NP. So since NumPy is a Python library and a module, so we have to first import it. So import NumPy as NP, because NP will give me the flexibility to use NP dot the function's name of NumPy without writing NumPy everywhere. Okay. So in this program, what we'll do is that we'll be creating a company sales analysis program in which there is a company, let's say there is a company and they are doing sales for a year. So now we want to generate which year was the best, they had sales, which year was the worst for sales, what was the total sales of the year, the average monthly sales, and then we print the worst month, the best month, the average month and the below average month. So all of these will print here and the input will be taken by the user. So I will not hard code the data here. The inputs will be taken by the user at runtime, and whatever sales the users enter, according to that data, the analysis will be given using NumPy functions of sum, of mean, of max, of min, and others. So what are they? We'll see that in this program. So here I have taken months, and here using the np.array function, I'll be entering a few names. I'll be entering all the months of the year. So starting with January. So since this is an array, so we'll be using the square brackets here. And the first is Jan. Okay, you can also write January, but Jan is small, so this is better. And separated by commas, and let's enter all of the 12 months here. So here we have entered all the 12 months of the year: January, February, March, April, May, June, July, August, September, October, November, December, and an empty array with the name of sales. Okay, so what is the functionality of sales? We'll see in the video ahead. So first of all, the user should get the message to enter the sales in $1,000 for each month. You can also enter the value below $1,000, but this is like minimum value that I have taken. Enter the sales value in multiples of $1,000. If you have less, you can enter less. If you have more, enter more. Whatever sales you have, just enter that. Okay. And I should give space here. Okay. So now, since there is an array here with the 12 values, there is an empty array. So here we will create a loop that will take each of the values here. This will first take January and then print and then take the value for January. Then this will take February, take the value and enter. Let the user enter the value for February, the total sales in Feb, and similarly for March, April, May till December. So this will take 12 values from the user, and after that the computation or the evaluation of that data will happen. Fine. So I'll take a for loop here for month in months. What is that? I'll just explain that in a bit. Let me first write the program. Value is okay. So what has happened here? Here we have taken the 12 values and here we'll ask the user to enter the sales for each month. So what will happen in this for loop, the month is the variable that I have taken and this will run over months. This is the months. This will take each and every value of months. So for month in months, take January 1st and in the value variable, this will ask the user to input the value for the particular month. So this is F is formatting. So this will take the value January and paste it here and the user will get for January. And so for the month of January, take the value. Then for the month of February, take the value. March, April until December, this will take 12 values from the user. Whatever values it will get, this will append it in the empty array that here it is. Sales is an empty array, so this will append it the values. So if I have entered 100, this will enter 100. If this 10,000, then the value next value will be 10,000. So this will be having 12 values in it. Okay. So this is the array that we have created. Now the next step is to change it or to convert it into an NP dot array. So this will convert the sales, that is this array, into a NP or the NumPy array. Okay, so this will convert or change the sales array to NumPy array. Okay, so once the array has been converted, so now we'll do the analysis. So the first is I should get a message that what is the analysis that we have generated. So company sales analysis. This the first line it will print is company sales analysis, what I have got here. Then again print the total sales. Capital of the year that I have got. So when the user will enter the value, then that will take all the values and add all of that value and give me the total sales of the year. And that will use the NumPy sum function to take the value directly from the array and add all of that. And in the end, what it will do, that will print a dollar sign along with that. Okay. And what I'll do, I'll copy some of this so that I do not have to write this much and paste. Average monthly sales. np.mean, that will give you the average, and that will again run on sales because the sales is having the data. This one, this sales, the np.array sales, this sales. This is giving me the computation or the analysis on this value that has been converted to np.array. Okay, and here too the end value is a dollar. Okay, this much money you have in the as the average monthly sales. Again, print highest sales, in which month you will get the highest sales. Okay. Here we use max function, np.max. This will give me the maximum value of the value that I have. So the maximum value of all the values of this will be the highest sales of that year. Okay, so np.sales, and find the value in the sales array that we have created and give me the highest value, and similarly print the lowest sales as well. Okay, np.min, this was max for maximum and min for minimum. The minimum value will be the lowest sales, and the end value a dollar again. Okay, the other 4 or 5 lines will print. First of all, it will be the company sales analysis, then the total sales of the year by adding all the values of the 12 months that we will be entering at runtime. Then the average monthly sales. So what is the average that we have got per month? That is np.mean. Highest sales using max and lowest using minimum, right? So now the user wants to know, or the company wants to know, which were the best months, so that they can analyze, okay, that was the best month. So what was the strategy we adopted in that month? So we should adopt the strategy the whole year. So how to get the best month that we had? So it should be best month is, so we'll take 2 values here. I'll explain that in a bit. Okay, so here we have taken best month and the worst month. So which was the best month of the whole year? So this will take the value from months here, take the value, and then using the np.argmax, and using the function of argument, the maximum argument. So here what will do, it will take the maximum value that it has of the above 12 values and print that as the best month, and the lowest value, that is the argument that we have, the minimum value will be the worst month, right? So this is it, and which there is the last scenario that we want to get is the which month was above average and which month was below average. Print the number of months that were above average. Let's take a mean value. So according to that, which months were the above average and which months will the below average. So the below average months should get a new strategy, right? So for that we will take above average value, and from the months array that we had, what we'll do is that take the sales value here and compare it. So first of all take January, then February, March, April, the whole year, and then using the sales that we had here, that this has converted to np.array, compare it to the mean value. let's say the mean value is 5,000. So compare it to the mean value here. If the mean value, if the sales that we had for each month is greater than 5,000, then print that as above average month. And if the sales for the month is less than 5,000, then print that as the below average month. Okay, so this is it. This is above average and this is below average. Okay, so take each value here from months, compare it, and if they are less than or greater than np dot mean value, then print that as the above average and below average. Okay, so the values are taken here. We have to just print them now. So print the above average months above average and below average months below average. Okay, so this has printed above average months. Take the mean, below average, and print the value above average month. This will give me a list of the months that is greater than np dot mean and the below average month less than the mean value. Okay, so let's save the program and run it to see the result here. So the command is the name of the file is num.py. Okay, so enter the sales in dollar for each month. This is asking me. So for January, let's say I enter 2000. For February, 1000. March, 30,000. With a lot of sales that year. That month. April was not good, so I just got 700. Right? May, 5,000. June, 10,000. July, 3,500. August, 7,890. September, 1, 2, 3, 4, 5. And October, 9,999. And November was not good, so just 100. And December was equally bad, so 2,500. Okay, 250, right? Okay. Now there's an error, so let's go and check what is the error and correct that, and we'll come back again. Okay, so there were two errors. Instead of the round bracket, there should be square brackets because this is calculating using the array function. So arrays use square brackets, so that was a mistake. Save that again. I'll come back and we have to run the program again, enter the values again, right? So 2,000, 3,000, 30,000, sorry, 20,000. I'll enter the different values this time. 1,400. May was good, so 9,999. Then June was not good, so 120. July 450. August 1, 2, 3, 4, 5. September 9,900. October 20,000. And November was 40. And December 1298. Okay, this is the company sales analysis. Total sales of the year is the adding all the values that we have generated here. Add all the values here, and this is the total sales we have. The average divided by the total number. This is the average sales. The highest sales was 99,999 because this is the highest value that in the total values we have entered. So this is the highest sales. The lowest is 120 because lowest value. And now the best month was May because I made a good amount of money, and the worst month was June with the value of 120, right? So the above average month we got the average. What is the average here? The average is 17542. So the above average months were that were above this. That is the 20,000, 40,000, 99,999 and 20,000 in March, May, October and November. So March, May, October, November, they were the above average months, and the rest were the below average months. Okay, so this was the company sales analysis project that we did, and we used all the NumPy functions of of sum, of mean, of max, minimum argument, the maximum argument, and the minimum argument, right? So this was the program that we created. I hope you found this video useful. So if you found this useful, do not forget to give it a like and subscribe to the channel if you have not yet subscribed. Share this video to anyone whom you wish that they should understand or learn about NumPy. And this was all for this video. I'll see you in the next one. Till then, keep learning, keep growing. Thank you very much. Goodbye.